Okey, nampak slide? Nampak Alright, so based on the lecture video that has been given before, so this is a basic question that we are going to use, but for this topic the most important thing is we are going to use which formula? Okay, this one. Alright, we have magnification factor formula, and also we have transmissibility formula. Alright, so based on these two types of formula, we are going to use three different condition lah. So each of these condition, they have their own formula lah yang kita akan guna. So we have harmonic force, we have rotating imbalance, and also we have support movement. Alright, support movement. Okay, so let's have a look some question. Okay, this one, yang ni kita tengok this one first. Yang ni saya tak discuss lagi kan dalam video ke? Dah ada tak ada kan? Okay, so look at this question. Briefly, yang tak apalah. The figure shows a motor which is bolted, dah record dah. Bolted to a platform. Okay, the total mass of motor and platform is 200 kg. 200 kg. Okay, the motor has unbalanced parameter ME of 2 kg meter. Yang ni kita akan guna untuk second condition lah. The platform is supported by an equivalent spring damper of stiffness K 5 meganewton per meter and damping coefficient C 27,000 Newton cycle per meter. So determine the following. The motor is switched off and the base is vibrating in the form of Y 4 sin omega F T 4 sin 200 T millimeter, and calculate the steady state amplitude of the motor and also the force transmitted to the base. This is our equation. So we need to say that motor will switch off and then the base is vibrating. So what kind of condition yang kita ada? Which type of vibration? We switch off the motor and then the base is vibrating. Yang mana ni? Type yang mana? Yang base kan? Yang base. Yang base maksudnya we are going to use supporting base. We are going to use this formula, support movement. Alright, this formula. Alright. So we need to find X. Steady state amplitude is X. Alright, so macam mana nak dapatkan X? First adalah based on equation yang dia bagi, Y equals to 4 sin 200t millimeter. From here, apa yang kita boleh extract daripada sini? What is 4? What does it mean is 4? 4 is Y naught, isn't it? Y naught, which is 4. What is 200? What is 200? 200 is omega F. Omega F. 200 radian per second. Okay, and then from here, based on equation, kita ada XSS over Y naught equals to berapa formula dia? Formula ni dia akan bagi dalam exam, don't worry. Tapi kalau tak bagi pun tak ada masalah kan, semua pun bukan. Okay, so XSS of Y naught, set 1 plus 2 zeta r squared over set 1 minus r squared tambah 2 zeta r squared. Betul? That is our formula. So from here, kita nak kena dapatkan r first. We need to find r first. So how to find r? What is our formula of r? What is our formula of r? R equals to omega f over omega n. And then we don't know what is our n. Then we need to find n first. Omega n first. So how to find omega n? Omega n equals to sert k over m. Alright, which is k is 5 times to the power of 6 over m. Sorry, mass. Total mass is 200. And then our omega n must be 158.11 radian per second. So based on that, kita akan dapat R lah. So R is omega f 200 divided by 158.11 equals to 1.26. That is our R. Alright, then we need to find zeta. Alright, so what is our formula of zeta? Based on damping coefficient, 2 zeta omega n equals to c over m, isn't it? Then zeta equals to c over 2 omega n m. So zeta equals to c. What is our c? 27,000 divided by 2 omega n is calculated here, 158.11 times with m is 200. Okay, then what is our zeta? 0.427. 0.427. So dah dapat zeta, dah dapat r, then back to our formula lah untuk dapatkan steady state dia. So what is our XSS? Over 4. This one in dalam bentuk millimeter, betul, sebab mm. Then just convert it to meter lah. 0.004 equals to sert 1 plus 2 zeta. What is our zeta? Darab dengan 0.427 times with 1.26 squared. Okay, over sert 1 minus 1.26 squared and plus with 2 times 0.427 times 1.26 squared. Then find what is our XSS. Alright, so XSS kita akan dapat sama dengan 4.8 mm. Okay, so that is our answer. Dia nak XSS kan? So that is our answer lah. Simple je kan? You guna formula dan dapat lah jawapan dia. Okay, how about number 2? The motor is switched off. The platform is externally excited with force F0 sin 150 Tn. So means that motor still switch off, but the platform is vibrating daripada atas lah. Alright, so the steady state the steady state amplitude of the platform is limited to 2 millimeter. So we are given SSS 2 millimeter. So determine the maximum amplitude of F naught and also the force transmitted to the base. Force transmitted to the base. So macam mana nak dapat F naught? What is our formula? Kita guna formula mana? This one kan, harmonic force. Okay, harmonic force, which is kita ada X over F naught over K. Yang ni kita nak dapatkan dia. And then kita nak dapatkan Ft. So kita guna dua rumus ni lah untuk dapatkan F naught dan juga Ft. So how to find F naught? Then using this formula, okay. So then before that kita ada based on equation F equals F naught sin omega t, meaning to say that omega F now adalah 150 radian per second. Okay, radian per second. And then of course dia akan berubah lah dia punya R kan. So R must be omega F over omega N, which is 150 divided by 158.11 0.949. So that is our R. Okay, and then based on that kita boleh dapatkan nilai zeta lah using formula C over M. Then zeta would be 27,000 over 200 times 1 over 2 times 158.11. Then zeta must be 0.457. Okay, 0.457. Kalau yang tadi berapa zeta kita? Zeta kita tadi adalah 0.427. So sekarang dia akan berubah ke 0.457. Dan based on formula yang kita ada, dan kita boleh dapatkan nilai F naught lah. So formulanya apa? Panjang lah formula dia. Okay, this one. So X over F naught over K. So X over F naught, X dah ada kan? X adalah 2 mm. So 2 darab 10 kuasa tolak 3 bahagi F naught over K. K is 5 times to the power of 6 equals to 1 over 1 minus R kan. R kita adalah 0.949 square tambah 2 darab dengan 0.457 darab dengan 0.949 square. So dari sini kita boleh simplifykan dia, dapatkan nilai F naught, which is the answer is 8730.6 Newton. Okay, then once kita dah dapat this X, the value of X, then kita boleh dapatkan nilai Ft lah pula, F transmitted. Okay, so the formula adalah Ft over F naught, which is 8730.6 sama dengan rumus dia adalah 1 plus 2 zeta R squared set over 1 minus R squared square plus 2 zeta R square. So Ft over 8730.6 sama dengan 1 plus 2 zeta is 0.457 darab dengan 0.949 square over 1 minus 0.949 square plus 2 times 0.457 times 0.949 square. Okay, cuba kira. What is our FT? What is our answer? Dapatkan FT. Kira cepat. .323 atas bahagi 1 tolak 0.949 square tambah 2 darab 0.457 darab 0.949 square set 0.873 betul, darab dengan 8730.6. So FT sama dengan 1.3238 darab 8730.6 bahagi 0.873. 13238 Newton. Betul tak jawapan dia? 1323, lebih kurang lah. Alright, 1323 7.98. Alright, so that is our FT lah. Okay, number 3. Okay, sekarang ni the motor is switch on. Kita switch on the motor, then what happen to our system? Dia akan vibrate sekali motor, then dia akan ada vibration about rotating. Vibration about rotating. So means that kita kena consider this case as second case lah, case nombor 2 lah. Running an average speed 1200. Alright, average speed 1200. So macam mana nak jawab soalan 3? Kita nak kena dapatkan apa tu? The steady state amplitude of the platform is limited to 10 mm. Determine the value of damping ratio. Hence, find the minimum value of damping coefficient C. Dia nak damping ratio zeta dan juga damping coefficient C. So, kita ada rumus nombor 3, X over ME over M equals to R square over 1 minus R square plus 2 zeta R square. Okay, so now is we are given average speed. So what does it mean here? This is we call as omega F lah. Average speed omega F equals to 1200 RPM convert to radian per second 2 pi over 60. Then omega F will be 125.66. 125.66. Then from here we can actually find what is our omega n. Alright, omega n equals to sert K over M. Alright, then 510 power 6 over 200, then kita akan dapat sama lah. Alright, then R will be omega F over omega N sama dengan 125.66 bahagi 158.11 equals to 0.795. So that is our R. Okay, ME is given as, dia dah bagikan ME equals to berapa ME? 2 kilogram meter. Alright. So from here, as steady state pun dah bagi 10 mm dan guna rumus teruslah. So 0.01 over 2 over M. M here adalah M total lah. Dia bagi tahu M total adalah 200 kan. So 200 equals to 7 point R. R square is 0.795 square over 1 minus 0.795 square plus 2 zeta kita nak dapatkan zeta R sama dengan 0.795 square. Okey, cuba dapatkan zeta berapa. So then zeta mesti sama dengan 0.32 if I'm not mistaken. 0.3. That is our answer. So once kita dapat zeta, dan kita boleh guna rumus 2 zeta omega n lah untuk dapatkan C, new C. Okay, so 0.32 omega n is 158.11 C over 200. Dan C kita boleh dapat jawapan dia 2023.8 Newton second per meter. Okay, so that is our answer. Okay, boleh. Alright. Done. So next question. Ada soalan tak nak tanya before we proceed to the next question? Any question you want to ask? Tak ada, semua faham. Alright, please have a look. This question pula. A suspension system of a vehicle can be modeled as a single degree of freedom as shown in figure P13. Alright, so kalau in the real case, how many degree of freedom we can consider of suspension system? In specific for quarter car suspension system, how many degree of freedom? Yang ni dia just assume single degree of freedom. Right, so basically kalau in a real case, kita akan consider dia sebagai second degree of freedom. Alright, kat mana dia datang satu lagi tu? It comes from the unsprung mass. We call as unsprung mass. Alright, this one we consider as sprung mass, first degree of freedom. Another one comes from unsprung mass, which is from the tire lah. The tire adalah dia ada satu lagi movement, vertical movement from the tire. Alright, so but for this case, we just assume that this one is a first degree of freedom. Alright, for second degree of freedom kita akan tengok next topic lah, macam mana dia consider kan. Alright, so the vehicle move a road surface having an approximate profile of sinusoidal waveform as shown in the figure. Alright, the equivalent mass of the vehicle is 1000 kg. The equivalent stiffness constant 1 meganewton per meter, and the system has an equivalent damping value 16,000 newton second per meter. If the vehicle moves at a speed of 54 km per hour, and then we need to find amplitude of steady state vehicle body, relative amplitude between vehicle body and road surface, and maximum force exerted on the vehicle by the oscillation. Alright, yang ni biasanya sub movement lah kan, base movement. Base maksudnya kondisi nombor 3, third condition. Okay, so kita list out dulu apa yang parameters yang dia bagi. Kita ada M equivalent equals to 1000, and then we have K 1 times 10 to the power of 6 Newton per meter, and then C we have 16,000 Newton second per meter, and then V is given as 54 kilometer per hour. Okay, sekarang ni we need to find omega F, isn't it? Because from omega F kita boleh dapat dia punya nilai R. The question is how to find omega F. How to find omega F? Any idea? What does it mean here? 7.5 meter. What we can define 7.5 meter over here? And what is 0.8 meter? Apa dia? Displacement. What kind of displacement? 0.8 meter. What is that? Apa tu? Macam mana kita nak dapatkan equation of sinusoidal wave? Sinusoidal macam y equals to y naught sin omega ft. Kita nak dapatkan in terms of equation based on the given parameters here. Macam mana? What is our y naught? Of course, y naught is 0.8, isn't it? So how to find omega f? How to find omega f? How to find omega f? Come on, fizik ni. Macam mana nak dapatkan omega based on a velocity given and 7.5 meter. Tu apa dia sebenarnya 7.5 meter tu? What does it mean here? What is 7.5 meter? 2 pi r. 2 pi r tu apa? 2 pi r. Frekuensi. 2 pi r. 2 pi r or 2 pi f? Omega f equals to 2 pi f, isn't it? 2 pi f. F is frequency in hertz. So how to find f? How to find f? Macam mana kita nak relatekan 7.5 ni dengan velocity? What is our equation? Yang ni basic equation. Dalam soalan, dalam exam mungkin dia tak akan bagi because this is very fundamental formula that you must know. What is our formula? How we can relate frequency and velocity? What the meaning of 7.5 meter here? Cepat. Tak ada seorang pun boleh dapat formula. Okay, so kita tahu F equals to 1 over T. Betul? 1 over T. So, how to find T? T, 1 cycle. T dia tak bagi 1 cycle, tapi dia bagi distance 7.5. What does it mean here? Apa maksudnya 7.5 tu? Cepat. What is 7.5? Macam mana nak relatekan T dengan 7.5? Distance. Distance betul. Distance tapi in terms of what? Apa yang kita panggil this one? Kalau kita define as frequency, apa maksud frequency? Distance move in 1 second. So, in other words, apa kita panggil? Distance move in 1 second. What can we call over here? Lambda. Yes, lambda. Aduhai. So, lambda is wavelength. Wavelength. Kita panggil wavelength. Alright. So, this is our lambda, which is 7.5, which is distance the system moving in one complete cycle. Alright, one complete cycle. So the equation of V equals to lambda over T. Yes, correct. So ataupun terus kita boleh consider as lambda times with F. Kalau tak nak dapatkan T, terus dapatkan F, sebab kita nak kena dapatkan F untuk put our F to this formula. Alright. So V is 54 km per hour. Then convert it to meter per second first. Then we have 15, isn't it? 15 meter per second equals to lambda is 7.5 darab dengan F frequency. Okay, so then we can find what is our F. So F must be berapa F? 2, isn't it? Betul ke 2? 2. F is 2 Hz. Alright, once kita dah dapat F, then back to this formula lah untuk dapatkan omega F. So omega F is 2 pi times 2 equals to 12.6 radian per second. Alright. 2.6 radian per second. Okay, so once kita dah dapat omega F, then kita boleh dapatkan nilai R lah. So before that kita nak kena dapatkan omega N dululah. So how to find omega N? As usual, K over M. Alright, so what is our K? 1 times 10 to the power of 6 over M is 1000. So omega N would be, what is our omega N? 31.6. So from here we can find what is our R. So omega F over omega N, which is R is 12.6 over 31.6. So R equals to 0.4, isn't it? 0.4. 0.4. Alright, so once kita dapat 0.4, then kita boleh tak dapatkan zeta? Boleh kan, guna formula lah. So 2 zeta omega N C over M. Then zeta equals to C is 16,000 over 1,000 times with 2 31.6. So what is our zeta? What is zeta? Zeta is 0.253. Okay, so that is our zeta. Alright, so semua dah ada, zeta ada, R ada, then guna formula terus lah untuk dapatkan X steady state. So XSS over Y0. Y0 is 0.8 over formula 1 tambah 2 zeta R squared. 1 plus 2 zeta 2 times 0.253 times 0.4 squared over 1 minus 0.4 squared plus 2 times 0.253 times 0.4 square. Okay, then XSS sama dengan 0.945. So dari our answer lah. Okay, ada soalan nak tanya setakat tu? Any question? Any question? Tak ada? Alright, so number 2, relative amplitude between vehicle body and road surface. Apa maksud relative amplitude? What does it mean? What is relative amplitude? Perbezaan kan? Relative maksudnya perbezaan amplitude di antara vehicle body dan juga road surface. So, berapa dia punya perbezaan? So, XSS tadi set ni dah sebenarnya kita dah consider as vehicle body lah punya amplitude. Jadi, kita punya relative ni adalah X relative lah. Sama dengan 0.945 tolak dengan 0.8. Tu je lah jawapan dia. So, perbezaannya adalah 0.145. Okay. And last one, number 3. Maximum force exerted on the vehicle by the oscillation. Maksudnya dia nak FT lah kan. Maximum force maksudnya transmitted force. Transmitted force yang dia transfer it to the body. Alright, by oscillation. Oscillation maksudnya by sinusoidal wave yang berlaku. So, what is our FT? Just using formula FT over 1/10 kuasa 6 K times 0.8 kan. .8 and then K over Y kan. KY, sorry. Ini formula dia. Use which formula? This one. Alright, KY. Okay, and then equals to, terus kita ambil yang mana? Sekejap. Rumus dia adalah R square, ada tak muat pula. R square set 1 plus 2 zeta R square over 1 minus R square square plus 2 zeta R square set. Alright, so masuk semua nilai, put all together, then at the end FT you akan dapat 151,142 Newton. So dari our answer lah. Okay, tu je. So for this topic dia lebih kepada kita play around dengan formula dia bagi, dan you must know every parameters yang dia bagi tu. Apa yang dimaksudkan dengan parameter dia bagi tu lah. And then condition, sama ada condition nombor 1, nombor 2 atau nombor 3. Ada soalan nak tanya? Cakap tu? Tak ada. Alright. Kita tengok satu soalan from past year question. Yang ni question daripada tahun lepas, 2019, 2020 dan SEM 1. Alright. So total mark adalah 20. Alright, 20. Look at the first question. Yang ni dia lebih kepada derivation lah. In force dampened vibration system, Okay. Magnification factor equations are given by MF 1 over 2 zeta 1 minus zeta squared, or MF equals to M omega n squared XSS over F naught, and frequency ratio is R equals to omega F over omega n 1 minus 2 zeta squared set. Alright, if you realize that formula dia bagi dia tak sama dengan apa yang ada dalam table kan, but it's okay. Yang ni adalah formula yang dia dah derive based on new arrangement of MF dan juga R. Alright, with this equation dia bagi ni, dia suruh prove the given equation must equals to this. Alright, macam mana nak prove? Any idea? Bila ke kita nak prove, macam mana kita nak prove? Just masuk-masuk je lah kan? Masuk-masuk je dan contoh. Sekejap. So kita ada MF 1 over 2 zeta 1 minus zeta square. Dia ada 2 MF dan kita nak dapatkan kita nak kena provekan equation tu, jadikan dia sebagai M omega F square XSS over F naught 1 minus 2 zeta square equals to 1 over 2 zeta 1 minus zeta square set. Dua markah je tu dia bagi. So tak susah pun, just masuk je MF. First adalah kita samakan dengan this one dulu. Okay. And then lepas tu masukkan X mana tadi? Samakan yang 1 over 2 zeta 1 minus zeta square sama dengan M omega n square XSS over F naught. Sekarang ni masukkan omega n ni, gantikan dengan formula yang ni. Alright. Kita ada R sama dengan 1 minus 2 zeta square. Yang mana yang berubah ni, yang tak sama ni? F naught kan? Macam mana dia buat ni? M omega F square, yang ni M omega n square XSS over F naught. Ok, sekarang ni this one lah yang berubah. So dia tambah, dia gantikan omega n ni, alright, sama dengan omega F over 1 minus 2 zeta square set. Dan yang ni dia masukkan terus dalam dia ganti masuk yang ni, dan kita akan dapatlah M omega F square XSS over F naught 1 minus 2 zeta square. Okay, proven lah. Just masuk-masuk macam tu je. Okay, so number 2. Question number 2. A machine of mass 25 kg is placed on an elastic foundation. Okay, a sinusoidal force of magnitude 25 Newton is applied to the machine. A frequency sweep reveals that the maximum steady-state amplitude of 1.3 millimeter occurs when the period of response is to 0.22 second. Determine the damping ratio and equivalent system of the foundation. Use equation 4.1 and figure question 5, transmission ratio TR versus frequency ratio to solve the problem. Alright. So first step adalah dapatkan dia punya omega F first lah. So kita tahu T sama dengan 2 pi over omega F, isn't it? Alright, so omega F would be 2 pi over T, which is 2 pi over 0.22, which is 28.6 radian per second. So that is our omega F. So based on equation yang atas ni, this one, kita guna untuk dapatkan zeta first. Alright, dapatkan zeta. So kita ada M. M berapa? M adalah 25. 25. Omega F is 28.6 squared. And XSS is given as 1.3, which is 1.3 times 10 to the power of negative 6 over F naught. What is our F naught? This is our F naught. Alright. F naught is 25. 1 minus 2 zeta squared equals to 1 over 2 zeta 1 minus zeta squared. That is our equation. Then you can simplify this. You will get the formula, ataupun simplifiedkan lagi, kita akan dapat macam mana ni? Sekejap. Kita akan dapat 1.1 over, yang ni saya dah simplify 1 minus 2 zeta squared. Kita squarekan dia semua, equals to 0.5 over zeta squared 1 minus zeta squared. Alright. Simplifikan dia, then at the end kita akan dapat dalam bentuk kuadratik. Right, so the answer ataupun dalam equation kuadratik kita akan dapat zeta to the power 4 minus zeta squared plus 0.114 equals to 0. So simplify that one, then kita akan dapat dua jawapan, which is zeta squared sama dengan 0.869, satu lagi zeta squared sama dengan 0.131. Okay, dan simplifikan lagi. From here kita akan dapat zeta would be 0.932, another zeta is 0.362. Okay, sekarang kita dapat dua jawapan. Which one yang kita nak ambil? Nak ambil 0.932 ataupun kita nak kena ambil 0.362. Which one? 0.362. Which one? Yang mana kita nak ambil? Ataupun kalau guna calculator dapat lain sikit kot. Sekejap. Saya cuba. 1 tolak 2 0.114. Kosong 0.058. Cek lain je jap. Zeta 0.114. Satu tolak 1 0.114 Betul, 0.869 dengan 0, betul-betul 0.131 kan. Betul-betul. So dapat lebih kurang lah. Tapi yang mana kita nak pilih ni? Which formula ataupun which zeta yang kita nak pilih? Which zeta? Yang mana? 0.932 ataupun 0.362? 0.932. Why? Kenapa nak kena pilih 0.932? Yang ni kena tahu ni. Why we choose 0.932? Okay, let's say kalau kita pilih 0.932, you must remember that the larger value they must be discarded because frequency sweep would only dia hanya berlaku pada maksimum 0.707. Sebab tu yang ni penting. Sekejap based on formula kat sini, kita tengok kat sini, set 2. Okay, set 2 ni, sekarang ni formula yang kita ada adalah kat sini. Kita nak masukkan this one kan. Kita nak masukkan formula this one. Okay, contoh let's say kalau kita masukkan nilai 0.932, sekejap. Okay, based on formula kita ada kat atas ni kan, kita ada omega n equals to omega f over cert 1 minus 2 zeta square. What happen kalau kita masukkan nilai 0.932? Dia akan dapat not cert kan. Kita nak cert maksud dia akan dapat negatif. So negatif maksud invalid. So kita ignore lah yang tu. So you must make sure that the value yang you pilih ni mesti valid. Mesti valid maksudnya zeta yang lebih sesuai, we need to choose as 0.362. So sebab kita nak masukkan dalam ni 28.6 over 1 minus 2 0.362 square. Alright, dan baru omega n kita akan dapat lah. So 33.5 radian per second. Okay, clear? So if you choose 0.932, then we cannot get our value of omega n because cert negative will be undefined. Okay, so this is our omega n. Alright, so once kita dah dapat omega n, soalan dia nak dapatkan apa? Damping ratio kan. So damping ratio, inilah damping ratio kan. Sekejap, damping ratio tu apa? Zeta kan. Ini yang zeta yang kita dapat. This is our zeta. And then equivalent stiffness of foundation, kita dapatkan K pula. So untuk dapatkan K, then yes, kita kena dapatkan omega n lah, because we have a formula K equals to M omega n squared, isn't it? So M adalah 25, omega n adalah 33.5 squared, dan K will be 2.8 darab 10 kuasa 4. So that is our answer lah. Okay, and then lepas tu dia nak apa lagi? Tu je, dua tu je. So that is our answer. Ada soalan yang tanya? Faham tak? Faham damping ratio tu zeta? Yelah zeta lah damping ratio tu. Kena faham lah dia punya term-term tu. Damping ratio adalah zeta. Alright. Kalau dia beritahu resonan apa? Frekuensi resonan. Apa maksudnya? Kalau dia beritahu frekuensi resonan, omega n, yes. So frekuensi resonan adalah natural frequency. Kena tahu term-term tu. So kadang-kadang dia nak kita confuse. Dia bagi term-term yang pelik sikit kan. But tapi then sebenarnya dia sama je. Okay. Damping frekuensi sama dengan resonan ke? Damping frekuensi adalah omega D. Natural frequency adalah omega n. Alright, lain, tak sama. Alright, damping frekuensi biasanya kita akan guna pada free dampered of 1 degree of freedom. Alright, omega D sama omega n 1 minus zeta squared surd, isn't it? So that is our formula. Yang tu just implement for free dampered 1 DOF. But for this topic, we have force dampered, which is we use term omega F, force frequency. Ada beza omega N, omega D, and also omega F. Omega N adalah natural frequency, omega D adalah damping frequency, omega F adalah force frequency. So normally omega D damping frequency kita akan guna for topic free damping vibration lah. Untuk this topic kita akan guna omega F. Okay. Alright, number 2. Soalan number 2. A machine having 300 kg is mounted on isolators. The combined stiffness and damping constant of the isolators are 5 times 10 to the power of 6 and 3.125 times 10 to the power of 3 respectively. The machine is driven through a belt by an electric motor operating at a speed of 3000 rpm. So determine the vibratory amplitude of the machine at running speed due to harmonic force of excitation of 1000 Newton. Also determine the vibratory amplitude when the machine speed passes through resonant condition. Alright, so yang ni condition nombor berapa ni? Dia nak dapatkan XSS ni kan? Dia nak XSS, X steady state. Alright. So yang ni condition nombor berapa ni? Nombor 1. Betul nombor 1. Nombor 1 kan. So yang ni isolator. Maksudnya yang ni kita akan guna condition yang F0 over K. X nombor 1 harmonic force lah. Harmonic force. Alright. So first adalah dapatkan omega n. Find what is our omega n. Omega f. What is our omega f? 2 pi n over 60. Yang ni adalah omega f lah. Dia bagi 3000 tu adalah omega f. So 2 pi 3000 over 60, which is 314.16 radian per second. That is our omega f. And then after that, dapatkan omega n. So how to find omega n? Surd K over M. Right, surd K is 5 times 10 to the power of 6 over M is 300. Betul? M adalah 300. This is our M. So the answer is 1, 2, 9.1 radian per second. Okay, and then dah dapat omega F, dah dapat omega M, dan kita boleh dapatkan nilai R lah. Omega F over omega N. 314.16 over 12, 129.1. Okay, 129.1, then the answer of R would be 2.433. Okay, and then find zeta pula. So C over 2m omega n. So C adalah this one kan, this is our C. 3.125 times 10 to the power of 3 over 2 m is 300 times omega n 129.1. Then the answer of zeta or damping ratio is 0.04. Okay, so we have R, we also have zeta. Then back to our condition based on frequency ratio R. Alright, R ni adalah frequency ratio lah. Kena tahu dia punya perkataan. R adalah frequency ratio, zeta adalah damping ratio. Okay, so based on formula we have XSS over F naught over K equals to 1 over 1 minus R squared plus 2 zeta R squared. Okay, F naught dah ada kan? F naught adalah 1000 harmonic force excitation. So XSS sama dengan 1000 divided by K is 5 times 10 to the power of 6 over, yang ni set, lupa nak set, over 1 minus R, 2.433 squared plus 2 times 0.04 times 2.433 squared. Then so cuba dapatkan what is our XSS. What is our XSS? Berapa? Cuba kira. .062 times 10 to the power of negative 5. Betul ke? Negatif 5. Betul lah kan? 4.06 kan? Betul. 4.06 times 10 power of negative 5. So convert to millimeter. Then somewhere around 0.0406, isn't it? Millimeter. So this is our answer lah. Kecil je kan dia punya vibration, dia punya amplitude vibration. So which is very good lah kalau kecil kan. Okay, so next adalah soalan dia nak dapatkan determine the vibratory amplitude when machine speed passes through resonant condition. So apa maksudnya resonant condition? So apa yang kita boleh consider kat sini? If we have resonant condition. What does it mean here? Apa dia? Kalau berlaku resonant condition, so apa yang berlaku? Natural frequency. Okay, natural frequency sama dengan apa? Kalau resonant. Sama dengan apa? Resonant. Natural frequency sama dengan normal frequency. Normal frequency. Force frequency kan saya dah beritahu omega F, omega D, omega N. Kita guna 3 term tu sahaja. Alright. Force frequency. Alright. So maksudnya kalau berlaku resonant omega N, natural frequency sama dengan force frequency which is omega F. Alright. So bila sama apa maksudnya? R must be frequency ratio must be omega N sama dengan omega F. So apa maksudnya kat sini? Frequency ratio R should be 1. Alright, R equals to 1 lah. So once kita tahu R equals to 1 dan masukkan dalam formula teruslah. So XSS sama dengan F0 over K 1 minus 1. Betul. 1 tolak 1 square tambah 2 zeta R square set. So this is 0 dan yang tinggal hanya F0 over K 2 zeta R square set. Okay, dan masukkan formula nilai yang adalah 1000 bahagi 5 darab 10 kuasa 6 over set 2 times 0.04 times 1 square. Then X sama dengan berapa? Cuba kira. What is our XSS? Berapa? (2.5 times 10 to the power of negative 3). Then XXS must be 2.5 millimeter. Okay, so apa yang kita boleh conclude dekat sini? Bila berlaku resonance, then what happen to our amplitude? Kalau compare dengan the first one, what does it mean here? XSS yang the first one ni 0.04 kan, tapi bila berlaku resonance ataupun frekuensi sistem, force frequency sama dengan natural frequency dan dia berlaku resonance. So that's why bila nilai ataupun berlakunya resonance, dia punya sistem makin tak stabil lah, sebab dia menyebabkan amplitude lagi besar. So bila lagi besar, masa vibration lagi tinggi lah. That's why kalau kita tengok tragedi atau fenomena yang berlaku in a real situation kan, banyak kes yang dah berlaku. Contoh yang kes yang bridge tu kan, yang bridge tu kalau perasan video yang saya post dekat e-learning, yang tu one of the condition di mana omega natural frequency sama dengan frequency of the system. Alright, so macam mana dia boleh sama tu? Sebab disebabkan angin yang kuat ataupun keadaan cuaca yang teruk menyebabkan natural frequency dia boleh mencapai pada tahap frekuensi yang sama nilai dengan frekuensi of the system. So bila berlaku keadaan macam tu, dan dia akan berlaku a bigger amplitude pada bridge tersebut. So that's why menyebabkan force yang support for each load ataupun each point of force kat situ, dia menyebabkan dia tak boleh nak sustain lagi dia punya force yang berlaku disebabkan oleh vibration paling yang tinggi sangat tu. Itu adalah one of the example lah yang berlaku disebabkan oleh natural frequency yang sama dengan frequency of the system. Okay, so I think dah habis masa dah. So saya rasa setakat cukup untuk hari ni. Ada soalan tak nak tanya? Then we just finish our topic for force dampened frequency 1 DOF. Any question that you want to ask before we leaving? Tak ada, semua faham topik ni? This one will be question number 5 for your final exam. Alright? For your final exam. Satu lagi chapter, yes. We have one more chapters. By today saya akan masukkan video last chapter, and then next week, mungkin hari Rabu, kita akan conduct last class lah. Last class, dan lepas tu dah tak jumpa dah kan. So last class, dan kita akan discuss lah beberapa soalan regarding on that question. Alright, memang kena jawab soalan. Yes, compulsory. Yang pilihan hanya soalan 1 dan 2. Alright, soalan 1 dan 2. You can choose either question 1 or question 2. Question 3 until question 6 is compulsory untuk jawab. Alright. Dia punya implementation of final exam, I think all of you dah tahu kan. So I believe that you already received the procedure, the video of procedure for final exam, isn't it? So we are going to separate into 2 parts. Alright, 2 parts, part 1 and part 2. Part 1 would be question 1, question 2 and question 3, and part 2 will be question 4, 5 and 6. Alright, so part 1 belah pagi and part 2 belah petang, right? Okay, so the detail of implementation for our course will be informed later lah. Masa dia depend on credit hour. Yes, depend on credit hour. Kita ada credit hour 3 jam kredit, dan kita akan bahagikan lah dengan 5 soalan yang kita akan jawab. So each of question you must only spend around 36, if I'm not mistaken, 36 minit. 180 bagi 5. Yes, 36 minit each question. Alright, 36 minit saja. Kalau macam sem lepas, kita ada 2. If each session tu, we have 2 types of submissions in it. First is interim submission, and second is a final answer submission for each session. But for this semester, school have decided that you must submit your final answer per question, as what we did during test. Alright, so you need to submit each question. After completing one question, then you need to submit your final answer, and then we giving you password. Alright, and then you answering next question, and then after that submit again, and this process will be repeated lah until question number 6. Okay, is that clear? No answer. Yes, interim answer ada ke tak ada? No interim answer. Just submit your final answer every question. Alright, every question. Meaning to say that for part number 1 morning session, you need to submit twice, question number 1 or 2 and question number 3. And for afternoon session, you need to submit 3 times lah, question number 4, 5 and 6. Okay, we just only giving you 10 minutes buffer for submission process for each question. Okay, any more question? Tak ada so nanti saya akan bagi detail balik dia punya working step